So in question number 12, we have a beam resting on two pivot points. The beam has a length of 6 meters and a mass of 90, and the pivot on the left end exerts a normal force N1 on the beam, and the second pivot point, placed 4 meters from the left end, exerts a normal force N2. A woman of mass 55 kilograms steps on the left end of the beam and begins to walk to the right, as shown. The goal is to find the woman's position when the beam begins to tip. A. Sketch a free body diagram labeling the gravitational and normal forces acting on the beam and placing the woman a distance of x meters to the right of the first pivot, which is at the origin. All right. So we end up with something like this. There's the force of gravity on the beam, the force of gravity on the woman, and the two normal forces. We don't know normal forces because we don't know distance x yet. B, where is the woman when the normal force N1 is the greatest? Well, as she walks over towards the right, you should discover that N1 gets smaller. So where's she at when it's the greatest? The answer is when x is equal to 0. And so our first answer is here. So for B, it's when x is equal to 0. She's literally on top of that point. What is N1 when the beam is about to tip? Now, this gets a little bit more exciting. When she's right here, it's beginning to tip. We're pivoting around this pivot point right here. At that point, N1 should be 0. And it will have no force at all on it. And now the next question is, what is N2 at that point? Well, N2 is supporting the entire weight of everything. And so you should discover at that point it should be the sum of 900 and 550, or it should be that number right there. Next question. Using the results of that and the torque equilibrium, the torque's computed, find the woman's position when the beam's about to tip. All right. Now, a little bit of a bugaboo on this one. The distance x is measured from this side. And since we know that the center of mass of the beam should be, the pivot point's 4 meters, this distance right here from the pivot point over is going to be x minus 4. Why? Because this distance from here to here is already defined as 4 meters. The other thing I need to point out is the length of the beam is 6 meters. So how far is this from this point? The answer is this should be just 1 meter. Since we know this is 3 meters over to here, and this is 4 meters over there, this should be just 1 meter over. All right, so solving this. Torques clockwise equals torques counterclockwise. Relative to that pivot point I've shown, the 900 is trying to rotate it counterclockwise, and it's 1 meter away times the sine of 90. And this is going to be 550 times x minus 4, this distance I specified there. If you solve that, you'll discover that x, measured from the far side, should be 5.64. And now, the next question. What if you measure it, or calculate all the torques, not from this pivot point, but from a pivot point on the far side? Now, how are we going to get it? Well, this distance from here to here is going to be 3 meters over to this force, where it's at the center of the board. And again, reminder, this distance right here is 4 meters over to where this is applied. So pivot point there, we're going to do the exact same thing, but this time we've got just one counterclockwise torque. That's this force times the 4 meters. Equals the clockwise torques, which is going to be this 900 times the 3 meters, plus 550 times x, where x is how far it's away from that side. If we solve this, you get that, and believe it or not, you end up with the exact same answer. The answer is the same. Doesn't matter where you put the pivot point, as long as you do all your calculations for distance from that point, and all your calculations from torque from that point. I hope this helps. Have a great night.